More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home, real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hello everyone and welcome back to Mathnasium Schoolhouse. My name is Sandra, your instructor for today. Welcome back for those of you who have joined me before on some of my previous lessons. And in particular, I'm kind of building on a series that I did in the past where I looked at math and art and the connection of those two. So if you've joined me on those and you're curious about exploring that more in depth, that is exactly what we're doing today. We are looking at the math behind a very popular art topic, or I should say math and art topic, which is called tessellations. And I kind of tried to be creative with my title here, so it looks like there's three T words. There's tiles, tessellations, and then transformations. So we'll see how transformations fit into it. If you've played around with tessellations before, it definitely is something that your teachers might have introduced to you in the classroom. Then great, you have some background knowledge here, and I'm definitely going to ask you to help me out in just a bit. And tiles and tessellations, sometimes you'll hear those really used interchangeably, but there is a difference that we'll identify in just a bit. So let's get started then. We're going to work with a lot of visuals here, so I'm hoping that you guys can follow along with me. And for those of you that are joining us maybe for the first time at Mathnasium Schoolhouse, typically the structure here is about a 30 to 40 minute lesson where we explore one topic in as much depth as we possibly can within this time, really encouraging you guys to participate, help me out with some of the problems I pose to you. And if you do find anything challenging, or on the other hand, if you do find it easy to grasp for you, whether it's because you've explored it before or it's something that you're super interested in, as always, reach out to Nearest Mathnasium and we'd be very, very excited to help you out to explore this more in depth, or really help you, assist you in building those foundational skills to get you where you need to be for this topic. Enough about that. How about we carry on and do some math together? I'll be refreshing my screen to take a look at your comments here and there. In the meantime, I encourage you guys to help each other out. Say hello, let us know where you're coming from and what brings you here, what interest brings you here. So I'm going to get started by asking you guys pretty much to help me introduce the difference between tiles and tessellations. So I'm going to pose that to you guys first before I even write anything down on my board, and maybe I'll refresh my screen in the meantime. What is the difference between tiles and tessellations? And I can rephrase that in a different way and ask you, what do you see as the difference when you tile a plane versus when you tessellate? What is the difference there? If any. Maybe you guys don't know a difference, and that's fine. That's what we'll talk about today. And if you don't want to necessarily share any of those answers, at the very least, maybe some keywords that'll pop up in this discussion today, maybe you can do that while I just refresh here. I really want you guys to participate, which means I really want to be able to see what you guys are saying. So while that pops up for me, again, what are some keywords that pop up in these discussions if you've been with us, or sorry, if you've had these with the teacher before or you've explored it on your own? Let me maybe write that down. So tiling or tiles versus tessellations. This is a long word where, don't worry if you mess this up, I'm sure I've messed it up multiple times. 2 S's, 2 L's, 1 T. If you get anything from today's lesson, then that's an important one. How to spell tessellations. Oh, I see some French coming up. Bonjour. Very nice to see you guys are here with us. Yes, if you're having issues with the page, go ahead and refresh, much like I need to, so don't worry. We're both there. All right, I don't see any keywords just yet. I might have to refresh again. But some keywords that might pop up in here are repetition or repeating. Let me just write repeat maybe. I talked about tiling a plane, so possibly you've heard of that before, so we can use that. Maybe shapes, polygons, those are some keywords that'll pop up here. Maybe that gets you thinking about the difference there. So I'll kind of encourage the discussion here, again, before I refresh it one more time, just so I can see your comments. When it comes to tiling and tessellating, we're filling our plane. So pretend that this is my plane here, whatever you see on my whiteboard. I want to fill this in with shapes or polygons, whatever I decide, and we'll kind of talk about what works, what doesn't work. Maybe we need some combinations. We want to be able to fill it with no gaps whatsoever. So it's not as if, and I'm just going to pull up some of the blocks that I have here, I end up filling in my plane with a bunch of shapes. They need to be touching, all the edges need to be touching, so somehow I need to be able to perfectly fill it with no gaps, and on the other hand, also no overlapping. So I can't use like a quarter of this square for some reason. It's better shown when I draw it, but I can't overlap. So no gaps. I need to fill in all the space, and I also need to fill it in without overlapping. So a perfectly filled in plane. And one major difference between, and maybe the only difference between tiling and tessellating is that in tessellations, we're repeating a pattern. And so that's what we're going to be looking at today. If you love math, you more than likely love patterns. And even if you're not the biggest fan of math, but one area that you are a fan of is patterns, and maybe you are very much a visual person, maybe some art, you're intrigued by art, this is probably an area you're fascinated in because you can identify patterns and then use them and draw the most beautiful designs. And I encourage you guys, with the permission of an adult after today's lesson, to maybe go online and explore with someone in your family different tessellations that show up in the real world around you. And as I was actually thinking about prepping for today, I was thinking, well, maybe one way that it's actually shown up in your life over the past few months is maybe you've had your parents or your family members stay home due to, of course, the time in which we're living right now with this pandemic. And they've taken this as an opportunity to renovate something. And maybe that might have been something like tiling the kitchen floor or a bathroom floor. And that's exactly where these come into play, right? You put tiles together and you really want to make sure that there's no gaps. That's why you're tiling it, right? You don't want water or any liquids to get through. So you need to have a very tight squeeze of all these tiles, and you don't want to overlap it because that just won't look pretty. So think of it that way today. Let me refresh and see what else you guys are saying here. And let's maybe go on and explore what we can do with this. So let me share my PDF also. I have a document I want to share with you guys. And as I'm refreshing, I'd like you guys to take a look at this first image here. So this is just an image here where we've taken a shape, done something with it. We'll talk about those words as well. Also some keywords that pop up in this discussion. Filled in this bigger rectangle with these shapes. And I want you to tell me, is this a tiling or a tessellation? As I prepare my board here. Is this a tiling or a tessellation? And then we'll go through a few more just to make sure we're on the same page about the difference. All right. So one of the key differences that we talked about was that in tessellations, you actually have some part of your design, some pattern, whether it's one shape or polygon or a combination of them, and that's being repeated. But it's that exact same pattern that's being repeated. Can we look at this? And I know I'm not showing you the whole image on the screen. I apologize for that. But can you find one pattern that's being repeated here? I cannot, so we can definitely call this a tiling. Okay, because it is at the very least covering up, filling in the entire plane with no gaps. It's a bunch of rectangles, some smaller, some look like they're even squares, all the same sides. So there we have a tiling. What if I scroll down to this one here? So we've still filled in an entire plane. What do we think? Tiling or tessellation? Give you a few seconds there. Let's see what you guys are saying in the comments. And so again, you might want to ask yourself, is there repetition? In that first one, no repetition, okay, but it was a tiling. Because there were no gaps, no overlapping, we filled in the plane. Great. Okay, you guys said tiling for that first one, wonderful. Great to see that you guys like patterns. So for this one, we're gonna say that this is actually neither. So I'm sorry if you think that that's a trick question. Hopefully some of you got that, right? There is a repetition that is occurring, but what are one of those conditions that we talked about for both tiling and tessellations? We said that there can't be any gaps, has to be that really tight fit. So that one unfortunately is not a tiling or a tessellation. How about if I show you this third one here? What do we think? Hopefully the second one gave you a few clues. Okay, we're getting a deeper understanding of what tiling and tessellations are. It looks like we have repetition here, wonderful. So there's a potential that it's a tessellation, and it doesn't look like there are any gaps or any overlapping occurring. We filled in that entire plane, at least what we assume is the plane. And we can get into deeper conversations here about what it is that we're tessellating. What is that pattern that's being repeated? And in this case, if you want to jump ahead, it does look like, hopefully it's big enough on your screen, that it is a hexagon. So it's as if we took this hexagon that I have here and we placed a bunch of them together, and we'll explore this in depth. We can actually tessellate using a hexagon. So that one is a tessellation. Let me just write T-E-S-S. How about if I scroll down and I show you two more on the screen here? Hopefully not a trick question. Hopefully that one on the left side is a very quick tessellation because it is, of course, squares. It just looks like actually grid paper, right? A snippet of a piece of a sheet of grid paper. So it looks like squares being repeated, filling in that entire part that we're seeing. No gaps, no overlapping, that looks good. It's a tessellation, and I can pull up my squares here, which I have in orange, if you're able to see that. And squares can beautifully fill up a plane, but again, we know that because we've seen grid paper hopefully by now a lot, right? So that can definitely fill up our plane. And what about this one on the right here? Although it looks a bit tricky, can you identify something that is being repeated in here? And hopefully, as I was talking about the image on the left, you were able to see on the right that, something is being repeated here. And that something is a six-sided shape, so it's a hexagon. And because it's not one of those perfect hexagons that we're used to seeing, what we refer to as a regular hexagon, which would normally have equal side lengths and equal angles, it's an irregular hexagon, and there's a few of them that are being repeated there. Okay, so there we go, a tessellation as well. Beautiful. So let's continue this conversation. By now, we should understand the difference between tiling and tessellating. Important in a sense that now we get to talk about and observe what can we tessellate, what can we fill a plane with, what are some of those conditions we need to not have any gaps, to not have any overlapping shapes or images, and yet have a repeated pattern. So let's take a look at that. Because at the end of the day, we can fill in a plane, sure. But we want to make sure that it's something that's being repeated. So the question here is, let's do some observation with just one shape. Let's just simplify this for ourselves first. So a few questions there. Can you tessellate with squares? Yes, we just talked about that. Very simply, I have only 4 squares here, but I can continue this pattern across my whole whiteboard if I chose to. So yes, that one's fairly simple. I'm going to jump to the triangles just because I have the pattern blocks here. I have a bunch of equilateral triangles here, an added challenge to you might be to explore different types of triangles. But let's just see, can I tessellate with triangles? I'm just going to put some of them together. It looks like this is really nice to me, supposing that I don't ruin it. Not only does it look like I can tessellate, and if I had many, many more triangles, I'd be able to fill it in, but maybe you've made an observation just the way that I've put the triangles together, and you've seen that they create coincidentally meaning the same size as this hexagon, and we've already talked about how hexagons beautifully tessellate. And there's a reason why they beautifully tessellate. So before I kind of give away that answer, hopefully you guys are thinking about, well, why does this work? And why would something else not work? So we'll get into that in just a second. Now, the other question I have there are arrows. Could I possibly draw an arrow? So let me remove this and tessellate with it. I don't have a pattern block that is an arrow, but let's assume I had one like this. Could I tessellate with it? Possibly, depending maybe on how I drew it. So maybe I could draw the next one like this. Okay. And then it looks like maybe one could fit in here. And then maybe I could fill one in here. Possibly. Let's do this one first. No. So maybe I couldn't. Right? So maybe it's a matter of playing around with it and seeing what we can tessellate with and what we cannot, unless I messed that up. Okay? So what you could do actually, and this is a great way to play around with it, is if you don't have pattern blocks, and maybe I don't have it here, you can trace your own arrow on a sheet of paper, maybe a thicker cardstock, cut that out, and use that as your pattern block, and trace it around on your sheet of paper and see if you can fill in at least a part of that paper, sheet of paper with a tessellation made of arrows or any other shape that you're interested in. All right? And an added challenge to that would be, what if I change the angles of these arrows or the lengths of them? Maybe some of them work, some of them don't. So I'm going to scroll down there, and that just make an observation here that here we're tessellating with just one shape. And the question I want you to start thinking about is, can we tessellate with more than one shape? So let's try to investigate that in just a bit. I'm just going to remove this from my screen. Just scroll down here. So we've talked about, before I kind of reveal the next question, we've talked about tessellations, we've talked about what it means to tessellate, we've seen examples with shapes that work, possibly some that do not, so possibly with my arrows that wasn't working. Maybe it would, maybe if I just played around with some manipulation of that arrow, it would have worked. So the question is, how can I describe tessellations? How can I describe what's happening here? And I'll give us some examples in a bit too. Some of you are probably thinking, this is probably where that third T word comes into play, transformations, right? So with transformations, we're better able to describe what's happening with those repetitions in a tessellation. And we're better able to do it because we can speak of it mathematically, okay? So I want you guys right now, so I'll give you a few seconds before I refresh just so I can see some of those answers. Given what you've already learned from your own math classroom, from your own math teachers, what are some examples of transformations? So without even thinking about how they might show up in tessellations just yet, what are some examples of those? Give you a few seconds and then I'll refresh to see what you guys have come up with. And maybe I'll just show my entire whiteboard actually. I'm going to move this up because there might be quite a few that you guys share with me. So the question is, what are some transformations you've learned about? Meaning, if I take my shape, what are different things that I can do to it to transform it so that, yes, potentially I can fill in my whole plane with those transformations? So maybe I'll leave a few shapes here for you guys to think about. What could you do with those? Just need to see what some of your comments are. Okay, I'll give away one, and I'm assuming that this will be the first one I see. One thing that we can do is translate. I'm seeing a few here that maybe aren't. Okay, I haven't seen any just yet, that's fine. So one thing that we can do is translate. So if I have my hexagon here, I can translate it if I was on a grid. So that'll be maybe a separate schoolhouse lesson. If I was on a grid, I can instruct whoever's designing or drawing this tessellation to move this up or down, left or right, but essentially moving this shape across my plane. So that's the ability to translate. What about reflect? There's another one, right? So we're able to reflect across lines. So I can reflect across this vertical line here, or across this horizontal line here, and potentially other lines too. We'll keep it at that for now, horizontally and vertically. And what about a third very popular one, which is the rotation, right? And if you remember learning about rotations, maybe as early as grade 2, depending on when your math teacher introduced you to it, we need to identify some point by which we're rotating. So let's assume it's on this shape's vertex. I can rotate it some degrees here, or some amount of a turn here, maybe a quarter turn, a half turn, and so on, but I can rotate all about this point. Okay, so we can perform rotations. I'm going to add a few more to there. Maybe not necessarily a transformation as you might think of it, but symmetry definitely can hold for our tessellations. Okay. And what are some combinations? Again, I'll give you a few seconds to think of that. What kind of combinations of these transformations can I use? And how could they possibly show up in my tessellations? Okay, so before I kind of talk about a combination, I'm going to add in scaling. Sometimes we're seeing that, where scaling we can see the shape grow bigger, possibly smaller. Okay, and I'm going to add one more here, which will be a glide reflection, which here it'll be a reflection and a translation. All right. So let's take a look at some examples and see where we can observe them. So I'm going to show you some images of a tessellation in just a second. You're going to help me identify, or in other words, describe the tessellation. And note, one other piece of information that we need to know when describing a tessellation is, what is it that we're tessellating? So what is that pattern that's being repeated? So let's try to identify that, as well as the transformations that are being used to create that entire tessellation. So again, I'm going to share with you my document here. Scroll down. So what else do we need to describe a tessellation? Like I said, we need that tile that's being tessellated. So let's describe some of these here. So I'll leave these 3 on the screen right now. Clear up my whiteboard. See what we can come up with here. How can we describe this tessellation here? Okay, so first of all, what is that image, or what is that tile that is being repeated? It almost looks like it's that yellow, for me, I just see a cube altogether. So this will be the yellow. Maybe I'll put a Y there for the yellow, then that green there, then that orange there. So it almost looks like that is what is being repeated, okay? And what do we use there? What transformations are we using to create that entire tessellation? So definitely one that holds is a translation. I'm moving right and left. It almost looks like I'm going down and right, down and left as well. If I look at the very top image, which is where we can use that combination potentially. Okay. What else do we have there? Reflection. If I look at the top two images, I can think of, forget about the color for now, I can think of it as a reflection in that vertical line. Okay. So that's actually, maybe that's a good comment to make there. When you're looking at tessellations, try not to think about the color. The color is just added afterwards for the design. Let's look at the shapes themselves, how to create that design in the first place. Okay. Let's go to that second one there, so the blue and the gray one. That one might be fairly, depending on how you look at it, and that's the beauty of tessellations, is everyone, and artists in their own way, will be able to look at these designs and see the tessellations as different images that are being repeated. So you might see that entire line at the top there is what's being repeated, so it's being translated downwards. You might be able to break that down into a repetition in itself. So if you look at that entire blue line at the top, so I'm just using color here to assist us in this discussion, it looks like it's created from its own repetitions, its own translations, its own reflections, if you want to look at it that way. So there's multiple transformations we can use here to describe the tessellations. Hopefully you're seeing that as well. And then let's look at the third one. That one's a fancier one, I would say. And I would also add that's maybe a tessellation that we're most used to seeing. I've seen that one several times out in the real world, namely in tilings themselves, in a house, for example. Sometimes backsplash in a kitchen. That's a very popular one I've seen. Okay. The shapes there that we're seeing, this is probably a very, very simple tessellation to describe. We're just seeing rectangles. So if we look at the rectangles, ignoring the colors, the different shades of gray, it's the rectangles that are being repeated. Okay. And then let's talk about the transformations in that. So it looks like we have rotation occurring, because not only do we have a rectangle that stands upwards, it then maybe rotates to get this one here, depending on where you're looking. And then maybe this is the one that translates downwards. Okay, if you look at I'm looking at the light gray. Again, it depends on how you're looking at it. And you might then, instead of looking at rotations, look at the others the same way. So I believe it's something like that. Okay, and you just keep on going. So pretty cool, right? It's pretty cool to see that this math itself is actually used when you're tiling a floor. So when you're walking in your house today, or maybe you're leaving your house for the first time in weeks, or you've done it over the last few weeks, maybe you're looking at the world around you in many different ways, and you're noticing some of these designs and patterns in the architecture around you that you've never observed before. So I encourage you to do that. And before we end off for today, I definitely want us to observe what can we tessellate, what can we not tessellate. So let's bring a little bit more math into this. So how about you guys share with me, what are we able to tessellate and what are we not able to tessellate in terms of shapes? What are some of those properties we look for? I'm just going to prepare a document here. And a few other questions I want you to ask yourselves are, do we need to use only one shape? By now we should be saying pretty quickly to that question, well, no, we've seen tessellations with many shapes. Do we need to use only polygons? That's a fair question to ask. And do we need to use only regular polygons? Will all regular polygons work? There's another question to ask ourselves. Okay, so let's observe. We've definitely seen that three-sided shapes work nicely. We've talked about triangles. At the very least, we've identified that equilateral triangles work, but we'll see how it holds for more than that. Squares, we've talked about enough already. So we have the three-sided polygons. We have the four. What about pentagons? So unfortunately, I don't have a pentagon pattern block with me, but there's a question I want you guys to ask yourselves before we observe it on the whiteboard. Can we tessellate with pentagons? If so, why? If not, why not? And the only reason I'm not showing you right now, like I said, is I don't have the pattern blocks. We have identified hexagons as shapes that work. So what about pentagons? And I'll do my very best to draw a pentagon, a regular pentagon. I don't promise anything that it will be any good. So there we go. That definitely doesn't look like a regular pentagon, but it's as close as I can get. So there's our 5-sided polygon, a pentagon. What are your thoughts? Will this work to tessellate my plane, or will it not? So to answer that first question for us, do we need only one shape? The answer is no, right? We've kind of already seen that in some of the examples I've shown you. Sometimes we actually need, it's not only that we want to tessellate with more than one shape, we actually need 2 or more to tessellate to tile that entire plane with a tessellation. Okay? So the next question to ask ourselves is, well, what shapes do tessellate? We've talked about, like I said, triangles, squares, hexagons. So let's stick with the pentagon right now. And I'm going to tell you that a pentagon actually on its own will not work. And there's a reason behind it. There's a mathematical reason behind it. And it has to do, and I'll show you an image in just a bit, but it has to do with the fact that its interior angle, which if you're iffy on how to find that, there's a separate schoolhouse lesson on that, is actually 108 degrees. Now, why is that important? If I wanted to just use pentagons to fill in my entire plane, let's assume it's just the portion of my whiteboard you're seeing here, I'd want to then, let's say, place a pentagon here in my poorly drawn tessellation, so please don't judge, which would mean I have 108 degrees here, I have 108 degrees here. Okay. Would I perfectly be able to fit in a third pentagon here? The answer is no, because if I tried, I'd have to make sure that this fills up the entire degrees of a full circle, which is 360. But what is 108 degrees? 3 times. Okay, if you try that out, we get 324 degrees, which is not equal to 360 degrees. Not only is it not equal, but whatever amount we have left, the difference between 324 and 360, which is 36, is less than a full interior angle that I would need for a pentagon again. So why does this not work? Why do pentagons not work? And I can show you an image. So what I've been describing is beautifully put in our Mathnasium work here. Okay, so we have 3 pentagons trying their best to tessellate, but there is that gap. And remember, we talked about tessellations, and when we're tiling a plane, we're not allowed to have those gaps. And a 4th pentagon, unfortunately, would not work. So why does it not work for a pentagon? But why did it work for our triangles, our squares, and our hexagons? Give me a few seconds to think about it before I give you that answer. And it goes back to our interior angles. Okay? So although we could not have enough interior angles to create a full circle, the beautiful thing about triangles is that each interior angle there is 60 degrees. In a square, of course, it's 90 degrees. And a hexagon, if we find that, is 120 degrees. And the reason that's beautiful is because each of these are factors of 360. So 360 is evenly divisible by 60, 90, and 120, which means if we put these maybe not side by side, but enough of them together, so 3 of them here, you can see 120 plus 120 plus 120 adds up to be 360. Same goes with 4 of my squares and 6 of my triangles. Pretty cool, right? Pretty cool that we can, before we even try to tile a plane and tessellate, we can see if shapes are going to work based on their angles, right? And the other thing is that if we tried any other shape, as we saw, or any other regular polygon, I should say. Let's not jump to assuming that any other combinations won't work. We're going to find a gap, or they'll have to overlap. And again, another challenge I encourage you guys to take a look at. So before I end off for today, of course that means that those are the conditions for regular polygons, but that doesn't mean that we can't still tessellate with these shapes. So a polygon can still be used in your design. It just means that, like I said, we have to bring in another shape. So in this case, we could bring in this shape here, which you can see in the tessellation. So we can still have pentagons side by side, but we have to account for that gap and just include it into our design. Okay. And another thing I just wanted to mention here is that it doesn't mean that we can't then jump to irregular pentagons. So a very popular type of pentagon we can use is called a house pentagon, and hopefully that makes you think of exactly its name, something like this. It's still a 5-sided shape. It's just not regular, but it's still an irregular pentagon, and we can tessellate with this. So that's one shape that I encourage you to play around with. That'll be part of your assignment. Your assignment for after this schoolhouse lesson. So try it out with an irregular pentagon. And then ask yourselves, can I tessellate with, let me put this the right way, shapes that do not have straight edges? So the question is, can I tessellate with the circle? I'm going to encourage you guys to think of that. Again, if you're interested in the answers, reach out to your nearest Mathnasium. I know that our instructors would be more than happy to explore that with you. All right. But think about, can you? And then if you find the answer, prove it. Take out a sheet of paper and fill out that sheet of paper with your irregular pentagon, with your circle, if it works for you. And if it doesn't, try to find out why not by trying to and attempting to tessellate on your sheet. I'm going to leave it there for today. As I said, I'm not leaving you with a practice sheet this time because I really want to encourage you guys to take out just your sheet of paper and try to tessellate with different shapes and explore on your own what works, what doesn't work, and how can you know well in advance whether it will or will not work. Again, doing some of that math behind the scenes, what sum of angles will work and what will not. I'm going to leave it there for today. We will see you guys again this week. I hope you've seen the new schedule. Wednesday and Friday for Mathnasium Schoolhouse. So not tomorrow, but Wednesday and Friday. We look forward to seeing you guys there. Have fun in the meantime. As always, stay safe, smile loads. I hope you guys enjoyed. Bye-bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.